All right, gang, more on chi-square test of independence. I have to apologize up front. If I seem distracted, it's because I'm distracted. It's almost Christmas. I probably can tell up there, December 24th, 11 days away. The girls are home today, so that's a little bit more distraction, waiting on colleges. They're seniors, so they're applying to colleges, waiting on decisions. We have three coming in this week. The UPS and FedEx and mail being delivered is just a lot of stuff going on. So if I seem distracted, it's because I'm distracted. All right, so I'll do my best to stay on track here. So let's get some data. uh, in this extracurricular, uh, all the stuff that I did previously is all fine and dandy. Um, But typically what we have, as I explained in previous videos, is we'll have a data set that, um, if we read left to right, we get the cases, and then our variables are uh, on the columns. So what we have here is we have a grade, B or higher, and activity. So let's just see what this looks like. Let's look at grade. So we can see that the grades are dichotomized as B or higher or below B. And we can examine activity in hours. So it looks like there were 128 2 to 12 hours, less than 273 people, and more than 12 hours. So what we have here going on here, it looks like that we're going to examine the relationship between the student's grade and the number of hours that they uh, participate in extracurricular activities. So obviously the null would be hours in extracurricular activities, and grades are independent. And H sub A, hours in extra, and I'm not even distracted now. I just can't type for some reason. All right, are dependent. So in other words, they are related. All right. So also, just an FYI, when I put a hashtag in front of something, that means I can just type out text and communicate to you. And it's not R isn't looking for a command. So the very first thing I would want to do is set up a table. Again, I can spell, just can't type. And I want grade on. I think I want this to be activity in hours. I want that to be on the rows, and I want grade to be on the columns. So if I see that I have 48 students who got a B or higher that serve 2 to 12 hours extracurricular activity, and so on and so forth. All right. Now, it turns out that if we install a package called Gmodels, and we may have already installed it. I'm not sure. So I'll just choose Ohio. They all seem to be pretty stable these days. Used to be back in the old days when I first started using R, I think in, 2011, so almost 11 years ago. Some of the selections weren't as stable, but it seems like they're all pretty good now. And of course, if we install the package, we have to access the library. All right, so all's good. Now we can use something called a cross table. And what I'll do here is just look at the information in the table. And I want my chi-square to be reported, so I'll put chi-square equal true. I want my expected to be equal to true. I want those reported. I want my standard residuals equal to true. And I want the format to be equal to SPSS. Now, the default here is the SAS output, but if you use the SAS output, you can't see the standardized residuals. So we use the format SPSS so we can get the standardized residuals to show up. All right. And I want to, let's see, save this as just, we already have a model, don't we? So let's do new model. And what I like about this is it gives us a lot more information. So we can see that the format of each of the cells, each of these right now, the 48, the 53.581, and so on and so forth. First thing we get is the observed count. Then we get the expected. Then we get the chi-square contribution. Remember me talking about that last time when I wrote out the four cell contributions to the chi-square statistic? The third gives me that value, which is very helpful because it helps me identify the cases, or the cells, I should say, that have the most contribution to the chi-square test statistic. In fact, if you add up 0.581, 0.419, 8.847, you will get 21.06253, which is our chi-square test statistic. Okay. Um, Next thing we get is the row percent, column percent. Those things are cool. That's fine. And then the total percent. But then we get what I think is, other than the chi-square test statistic and the p-value, uh, we get the standardized residual, which is uh, extremely important. All right. So now we go down to the bottom and we see that we get the Pearson chi-square squared test. Let me tell you what will happen, and I may demonstrate this. I don't know yet. Um, if we have a 2x2 table, by default, this cross table command will give you two outputs down here. It'll give you Pearson chi-square test, and it will give you the chi-square test with Yates continuity correction. And as reasons that we talked about in the previous video, the chi-square statistic and the p-value will be different. Okay. So but let me explain some stuff going on down here. So we didn't do the Yates continuity correction because we shouldn't. We don't have a 2x2 table. That's the only time that applies. So our chi-square test statistic is 21.06. We have statistical significance at the 0.001 level. And right here is something very important. This is something you need to tattoo to the brain because it's extremely important. For the underlying sampling, okay, all the underlying sampling distributions that we studied up to this to chi-square had certain assumptions that have to be satisfied. Well, an important assumption for the chi-square statistic is that the minimum expected frequency, the minimum expected cell count, must be 5 or higher. Some people even say, use a more conservative estimate, and some say it should be 10 or higher. Either way, we're higher than 5 or 10. 5 tends to be uh, accepted in standard used in research. Okay, anyway, I'm getting on a tangent that's really not that important. So let's just agree on 5. That is kind of the industry standard. So 30.6 is clearly bigger. So what we can say by that is that our underlying sampling distribution, the chi-square distribution, again, we have a table here, a 3x2. So we're going to have a 2 times 1. So we'll have degrees of freedom equal to 2, right? Number of rows minus 1 times number of columns minus 1. So what we say is this underlying probability distribution, chi-square distribution degrees of freedom equal to, adequately models the calculation of the p-value. Now, The next thing I do is once I get statistical significance, I automatically get tunnel vision on the standardized residual. And what I'm looking for there, that's going to be the bottom entry in each of these cells, right? What I'm looking for here are any of these greater than 2 or less than -2. Well, you can see what happens here is I have the 2.974 and the -2.524 that just jump out at me. I mean, I'm concerned about the others. I will report those as well. But these two are the contributing factors to us getting statistical significance. Now, for example, what I can say for the 2.974 is I can say that the observed cell count is 2.974 times higher than the expected cell count. So for people who got grades of B or higher and served less than 2 hours of extracurricular time, that cell count, there were more people in that cell than I would have expected under the null hypothesis. Now, what's this tell you? Below B, -2.524. This tells me, probably doesn't even need to be written out, but I will. Now, but what does that really tell you? That tells me that there were less students. There were less students who earned below B, earned grades of below B, and served less than 2 hours extracurricular activity than I would have expected if there was no relationship between the two. So that gives you a pretty good indication that the component of the activity hours that contributes to the statistical significance is the people who are serving less than 2 hours. Specifically, the grades of B or higher are expected, are higher than we would have expected. The grades of B or well below B are lower than we would have expected. So that tells you that again that the number of hours extracurricular activities has a relationship. It's kind of you would expect. I would think. I don't know on final grade. Now, one thing that I want to point out to you, and I don't know if this is pointed, I pointed this out previously because we really haven't had any commands that have been that with that involved with a lot of kind of subparts. What you can always do is put like a question mark. If you, ah, and what will happen is a window will pop open and explain. Well, first of all, it gives you the format, right? And it'll give you all of the options. So there's one place. Well, I'm not sure how I knew that. Uh, well, I was trying to. Oh, here we go. Here we go. If we use the expected cell count, if desired, if chi-square equal true, which we did, in the case of a 2 by 2 table, both the corrected and uncorrected values will be included in the output. So that's just kind of supporting what I said earlier. So anyway, this gives you an idea of some things that you can actually include. So it's a pretty powerful. We'll get into a lot more. When we get into later on in this class or 6620, we'll get into log linear analysis where we can analyze the relationship between more than two categorical variables. And we'll get into some more sophisticated stuff there. But for now, I just want to keep this first lesson kind of simple. Well, gang, it seems like there was something else I wanted to show you, but I can't recall what it was. So I guess we'll end the video. If it comes to me, I'll start out with it in the next video. Take care.